Good morning or good day. Today we'll be looking at alphabet and string. Symbols include A, B, C, B, C, 0, 1, 2, 3 as symbols. So we're talking about alphabet as a string. In formal language, an alphabet or a vocabulary is a finished set of symbols or letters, for example, characters or digits. So what do we mean here? Let's look at what we mean here. We have symbols. Symbols. Then we have what we call character or vocabulary. What we call character or vocabulary. So and we have symbols as well. We have symbols. Symbols. So we say that alphabet in formal language, an alphabet or vocabulary is a finished set of symbols or letters, for example, characters or digits. So alphabet or vocabulary are finished set of symbols or letters, the finished set of symbols or letters. An example of symbols or letters could be characters or string. They could be characters or string. They could be characters or string. So one thing we should note here is finite, the word finite and the word finite set. When you say something is finite and set, you say something is finite and set. Finite means it has an end. Finite means it has an end, means end. And when you talk of set means group of something. That's the set. So when we say an alphabet or a vocabulary is a finished set of symbols and letters. That means it has an end, right? And it is a group of something. It means an alphabet or vocabulary has an end, it That's an end and is a set of something. So what are those things? They are symbols. They are finite set. That is, they have an end and they are group of something. That's just it. And what are the something? The somethings are the things are symbols. The things are symbols. The things are symbols. Those are the things. So let's read the definition to be clear. In formal language, an alphabet or vocabulary is a finite set of symbols or letters, for example, characters or digits. So let's look at what are the symbols. What are the symbols? What are the symbols? What are the symbols or letters? They could be characters or digits. For example, they could be character or digits. They could be characters or digits. So characters like A, characters like A, small letter A, comma, C, capital F. So they could be characters with digits like 1, 2, 3, 4, and they could be symbols. They could be symbols. Symbols like plus, negative, division, any symbol you can think of. There's another symbol like this, right? Or let's use ampersand. Ampersand equals to, so they are sets of finite symbols. In summary, they are set of symbols. These are the symbols. A, B, could be letters, could be digits, could be other symbols. You can invert your own symbols as well. If you wish, you can invert your symbol. Invent your own symbol. Let me try and invert a symbol. Maybe this symbol is not existing before. Let me say this is a symbol that is not existing before. Let's assume this symbol is not existing before. It might be existing, but we don't know. So these are symbols. So we say that in formal language, an alphabet is a finite set of symbols. So when it's not finite, it's a set of symbols that is finite. So if it's a set is a group of something, and it has to start with this bracket. So you now put the symbol in it, like let's say one, any form of symbol, or maybe you invent a symbol, you can put it. This has 3 objects. Let's assume that this one is invented. This one is 2 symbols that are existing. So an alphabet is a set of symbols. So this is a set of symbols, but it's finite. You know, a set could be finite or not finite. When a set is not finite, you can have a set like this: A, B, continuous set. Or let me use that one. Let me use this one. This one will be clearer. let me use this one as an infinite set. So an alphabet is a infinite set. An infinite set is like this. For example, one set of natural number are what? Are infinite sets. They continue till the end. You cannot stop. You continue to count them. So these are not finite. They are infinite sets. But an alphabet is a set of finite symbol. So, but a finite set must not have these three dots. It must not have these three dots. So 1, 2, 3 are finite sets because it stops. It does not continue. So this is an alphabet. You might not consider this one as an alphabet. Based on the definition we have, you might not. So an alphabet is a finite set of symbols. So what are symbols? Symbols could be letters, it could be character or digits, then you can invert your own symbol. So it's a set, and set must be noted as group of objects with bracket like this. So you now put your alphabet plus, it could be anything you want to put. So it could be made up of letters and numbers, anything, any symbol you like. So it's a set of symbols. It's a set of finite symbols. This is another alphabet. Alphabet is also known as a vocabulary. So an alphabet is a finite set of symbols. That's an alphabet. It's a finite set of symbols. That's an alphabet. So I hope that is clear. The first definition is clear. Let's go to the next one. Or an alphabet is a collection of symbols. Of course, a group of objects is a collection of symbols, like A, B, C. You can put maybe 100 here. This is a symbol. Oh, sorry. It's supposed to be a single symbol, not in group. So I put one. You don't usually put it like this. You usually put a single symbol, not in group. So an alphabet is a collection of symbols. This symbol 1, symbol 2, symbol 3, symbol 4. They are a collection of symbols. So examples of alphabets, we have, this is an example, A, B. It's an alphabet. D, E, F, G. It's another alphabet. Another alphabet is 1, 2. Another alphabet. In fact, we can say A is an alphabet, just a single alphabet. And we can have A, B. These are alphabets. How do you denote an alphabet? You denote an alphabet with using sigma symbol. Use sigma symbol to denote an alphabet. So if I want to denote any alphabet, I will use sigma symbol. For instance, just use this is the symbol for denoting alphabet. So when you see this is an alphabet. And what is it? A group of symbols, a finite set of symbols. So that is what we use to denote an alphabet. For example, A, B. We can put this one here. So this is an alphabet. Okay. So just like English language, as you have your ABC, you have your alphabet, you can create words from your alphabet. You can create words from your alphabet. So the next definition is a string or word is a finite sequence of symbols. Look at the word here, sequence of symbols. So a string or word is a sequence of symbols that are chosen from an alphabet. For example, here we have A, is a string, B is a string, C is a string, 0 is a string, 1 is a string, AA is a string, BB is a string, AC is a string, 01 is a string. We have how many strings? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now these are different strings, but the strings are created from an alphabet. String or word are created from an alphabet, just like the way we use alphabet in English, ABC, to create words. You can also use you can also use alphabet here under this topic, which is represented by sigma, to create string. So the definition of a string, you might be asked to define a string. A string of words is a finished sequence of symbols that are chosen from an alphabet, or a string or word over an alphabet is any finished sequence of characters. A string or word over an alphabet is any finished sequence of characters. Is any finished sequence of characters from an alphabet. Sigma represents alphabet. I've told you, to represent alphabet you use sigma. So you can say a string or word over an alphabet is any finished sequence. You can say finished sequence of characters chosen from an alphabet. For example, let's look at this example we have here. We are given summation, which is alphabet. This is our alphabet. Alphabet is 0, 1. You can create string from it. The string created over it is 0, 1, 0, 1. This is a string over our given alphabet, which is this, or what, or this, 0, 1. This is our given alphabet. Or you can even represent it like this. I hope you are seeing it. You can represent it like this. Or alpha equals to 0, 1. It's the same thing, right? So we can say that this is a string over your given alphabet, which is this, because we can write it like this: 0, 1. This is your alphabet. So this is a string over your alphabet. So you can write it like this alone. You can write it like this. Like this. You can write it like this, or over the alphabet, or you can write it like this, over this. So that's a string. So a string is a finished sequence. It's finite, right? Why is the string finite? We are saying from here you can write this string, right? Which other string can you write over this one? Another string over that one is 0, 1. Is 1, is 0, is 1, 1. All these are string. This is a string, this is a string, this is a string. From or over this given alphabet. Over this given alphabet. 0, 1. So over this alphabet you have this string, you have this string, you have this string. You can have as many strings as possible. You can have this is a string over the alphabet, this is another string, this is another string, another string, another string. You can even have this is a string over this alphabet. So you can see that the string is finite. That's why we have the definition as finite. It's finite is the sense that it does not continue. It stop at 1, stop at 0, stop at 100, stop at. It's not something like this. When you write something like this, it's not finite. You write something like this, you don't consider this as a string. In this case, you see this one continues. So string does not it doesn't continue. It doesn't continue. The string we are talking about here does not continue. So this is a string, this is a string over from alphabet 0, 1. This is string. Okay, I hope that is clear. Or let me write it clear again before we move on to the next statement. Take a statement by statement. Given this alphabet 0, 1, the string you can create over this alphabet is 1. That's one string. This is another 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 string. You can create many strings from the alphabet. So, but if you say 1, 0, you say the string continues. For instance, let's say just string of 0 alone. You say 0, 0, 0, 0, 0. You can see that there is a pattern. This one is increasing. To keep increasing, the next 0 will be 4. Sorry, I'm not supposed to use that example. Sorry, we're talking about string. Okay, so what I mean is this: you cannot say a string is 1, 1, 1, 1. It is finite. This one means the ones continue. This is not a string, but you can see 1. You can see 1, 1. You can see 1, 1, 1, 1. This is a string. This is a string. This is a string. We do not consider this one as a string. We do not in this case. So that's why we say this one is finite. We didn't put dot dots to show that the 1 continue to repeat itself. The 0 does not repeat itself. The 10 does not repeat itself. The 1, 1 does not repeat itself. So it's finite. That's why we say it's finite. So this is a string without, it doesn't repeat itself continuously. You understand? It doesn't repeat itself. This is a string, yes. It's finished, it stops somewhere. This is a string, it's finished, it stops somewhere. This is a string, it stops somewhere. It doesn't have 3 dots that repeat itself. This one means repetition. So it's finished. So we have these are string over this alphabet. Over this alphabet, these are the string. You can create as many string of any length. Okay, this one is 1, a string of length 1 created from over this alphabet, over this alphabet. String of length 2, this is also string of length 2, this is also string of length 2 created from this alphabet. So that's what we are saying. So we are saying that a string of words is a finite sequence of symbols that are chosen from an alphabet. For example, A is a string. A is a string on its own. B is a string on its own. C is a string on its own. 0 is a string. 1 is a string. Those are string of length 1. This is string of length 2. This string of length 2. They must have been created from an alphabet, which is not stated there. I'm just showing you an example of string. So a string is also known as a word over an alphabet. Is any finite sequence. That's why we say it's finite. It's not infinite. It's finite sequence of characters that are chosen from certain alphabet. So we have this example here, as you can see. We have this example. And what's the example? The example is which you have in your note. Given this alphabet, you can create a string from it, which is, then we can say this string. This is a string over given alphabet. In this case, our alphabet is what? Our alphabet is equals to 0, 1. So these are my jottings. This is the notes. It's also the same thing they are trying to describe here. Okay. So we have that. That is that about that. Let's go to power of an alphabet. Don't forget summation is used to represent an alphabet. And an alphabet is also known as a vocabulary. Okay, an alphabet. So this is an alphabet. Now we want to look at the power of an alphabet. We want to look at string lengths. We want to look at languages. Okay, so started describing some of these terms here. So let's go to the next sentence or paragraph. The length of a string is the number of characters in the string. You know what a string is? The length of the sequence, and can be any non-negative integer. Okay. Now we now say that the empty string is the unique string over an alphabet of length 0, and is denoted by this or this. That's the empty string. Okay. An empty string is denoted by what? So what's an empty string? What's the length of a string? The length of a string, we told to describe the length of a string. The length of a string is the number of characters in the string, as simple as ABC. This is a string created from this alphabet. What's the length of this string? The length of this string is 1, this 1, this 2, this 3, this is 4. It have length 4. This is a string on its own. This is 1. The length of this one 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 is 1. This one is 1. This one is what? 2. This one, the length of this one. This BB, the length is 2. A, the length is 2. AC, the length is 2. O1, the length is 2. This one, O101, created from this one. Now, these strings are created from certain alphabets. They didn't tell us, they're just showing us, talking about this. These strings are created from certain alphabets. They did not tell us the alphabet they are created from, but they are just showing us as an example that these are strings. So this one is string of length 1. This is length of length 1 because it's 1. 1, length 2, AA, BB is 2, AC is 2, O1 is 2. Now, how do we describe the length of the string? As I said, the length of the string is the number of characters in the string. For instance, when you have 1, 0, 1, 0, 1, which is a string that is created over this alphabet, giving 0, 1. The length of this string is the number of characters in the string. How many characters is this one? 1, 2, 3, 4. The length of the sequence. So it's a sequence 1, 2, 3, 4. That's 4. And it can be any non-negative integer. What this one is saying is that it could be a number that is non-negative. What are negative numbers? Negative numbers are -3. Negative integer. Sorry, what are negative integer? What are negative? Let me write it this way. What are negative integer? Negative integer are -3, -2, -1. Those are negative integers. Positive integers are non-negative integers. Positive integers are non-negative. Non-negative will be non-negative integer, which is non-negative number. There are 3, 2, 4. So what they are saying is a string could be a non-negative integer. So a string, the length of a string, okay, we're talking about the length of a string is the number of characters in a string, the length of a string, and can be any non-negative integer. Okay, they're talking about the length of a string here. So this is just an illustration of positive and negative integer. So now the length of this string is what? Is 1, 2, 3, 4. So it's 4. So that is same thing as non-negative. It's same thing as what? This is a non-negative integer. Okay. So let me give me an example again. This is it will be any non-negative. The length of the string will be any non-negative integer. This is string, right? If I write 1, 1, the length of this one is 2. 2 is non-negative integer. Okay, it can be any non-negative integer. So any non-negative integer could be start from 1, 2. They are natural numbers. 3. They are also called natural numbers. So the length of the string could be 1, it could be 2, it could be 3. I hope that one is clear. If it's not clear, you can, on my YouTube, you can ask question, or see me or call me. Okay, call me if it's not clear. So what we are just saying is the length of a string could be non-negative integer. For instance, let me explain again for the last time before I go. Before I go to the next section, you can create string 1, you can create string 0, you can create string 1, you can create 1, 0, you can create 0, 1, right? You can create 0, 1. You can also create string of 1, 1, 0, 0, 0. So these are string. This is a string over this. This is a string created from here over this. This is a string. So this one is what? Length 1. This is a string of length 1. This is a string of length 1. This is a string of length 2. This is a string of length 2. This is a string of. These are string of length 3. So the length of a string is a non-negative integer. You can see 1, it could be 1, it could be 2, it could be 3, it could be non-negative, it could be 4, or this could even be 1 million. It could be 1 million. So it depends on, it could be 1 million. Depends on the length of the string you are writing. This 1 million, right? That's the length of the string. So if I want to write the length of the string, which is 1 million, from this our alphabet, I want to write the length of a string that is about 1 million. That would be 1. I can write it like 1, 1. That is 1 million, 1, 1, 1. 1 million has how many digits? 7. 1. So we have 3, 3. This string of length 1 million. Also write this 0, 0, 1. This string of length 1 million. So it could be a non-positive integer. Now we now have the empty string. We have the empty string. The empty string is the unique string over a given alphabet of length 0 and is denoted by epsilon or lambda. I think it's epsilon, right? And lambda. So you can also have empty string, right? Let me give a very simple example so that it will be a bit clearer. I'm not using string 0, 1 now. Let me say I'm using 1, 2, A. This is a string. Okay? No, this is an alphabet or a vocabulary, right? Let me give you another alphabet or vocabulary apart from that. It could be anything. I've told you that your symbol, you might create your symbol. I think I mentioned that you could create your symbol here somewhere. Okay, your symbol could be created. It could be digits. Your symbol could be numbers. It could be letters. It could be digits. Then you may even create your symbol as well. So an alphabet set of symbol, I can put plus here. You can put slash here. I can put A here. I can put 2 here. These are symbols. So these are an alphabet. This is another alphabet. Okay. So sometimes this an alphabet. Sometimes an empty string is a unique string. You can see empty string is a unique string over an alphabet of length 0. An alphabet of length 0 and is denoted by, so sometimes your alphabet could be 0. An alphabet could be 0. And when we say an alphabet is 0, it means it contains no symbol. Okay? So we're talking about string length, but the empty string is a unique string. Okay, let me go back. Sorry. Let me go back to my explanation. Let me explain that one. Let's read it. The empty string So there's a string that is length is a unique string over an alphabet of length 0. So what they are saying is this is a string. This is a string, right? This is a string. This one has how many symbol? It has 3 symbols or 3 objects. This one has this one has 4 symbols. So this one has 3 symbols. This one has 4 symbols. Abi? 1, 2, 3, 4. This one has 3. Where's my marker? Let me increase the size to this. So this one has 3. 1, 2, 3. But this one has 4. 1, 2, 3, 4. Alright. So, have I removed it? Control Y. Let me go back. So this one has, as I said, this one has 3 alphabet. This one has 4 alphabet. So you can create string from these ones. The ones we have been looking at, the alphabets we are looking at is 0, 1. We can also create string from 8. But there is an empty string that we created over an alphabet. And the empty string is of length 0. Now, let me use this as an example. 0, 1. 0, 1, you can create an alphabet of length 1 from 0, 1. Alphabet of length 1 is 0. That you can create string from this alphabet. String of length. You can create string from this alphabet. You can create string from this alphabet. String of length 1 is 0. This one string, another string is 1. Right? You can create string of length 2 from this alphabet. What are the string? What will string be to be? 0, 0, 0, 1, 1, 0, 1, 1. They are 4 in numbers, right? This one, there are 3 numbers. You can create string of length 3 from that alphabet. The alphabet is this. Let me write it again. We have 0, 1. We want to create string of length 3. 0, 0, 0, 0, 0, 1, and 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. They are 8 numbers. So this one string, this another string, this another string. These are string of length 3 and they are 80 numbers. Is that okay? So from this same, let me shift this one to one side. So kind of obstructing us here. So okay, so this is this one is string of length 2. This one is string of length 1, created from over this alphabet, over this alphabet. String of length 1, you have 2 string of length 1, 4 string of length 2, you have 8 string of length 3 over this alphabet. But there is a unique string over any alphabet. Over any alphabet, you have a unique string. The empty string is a unique string over the alphabet of length 0, and it's noted by epsilon or lambda, right? So your alphabet will also have length 0. So this one, as I said, it has this one has one length, we have two string. This one has four string. It has two lengths. This one has how many string? Each is three. We have eight strings of length. Each of which is of length 3. Okay, so this one is string 1, string 2 of length 3 till you get to the 8th string of length 3 created from this alphabet. Actually, you can also create alphabet of length 0. If you want to create alphabet of length 0, that means there is a unique alphabet that is a member of all alphabets. That alphabet is a member of all alphabet and it is denoted by this. It means this is a very small symbol. Let me write it again. Epsilon, epsilon, epsilon. Yeah, it's a very small symbol. Something very small like this. It means it's this, or you use lambda to create it. So let's create the empty set. The empty set is just represented like this. It means of no length, right? It's of no length. From here, you have length 1 like 1. You have length 2 like 10. Or we can say 1, 1, they are length 2. You have length 3 like from this alphabet. You also have length 3 like 1, 0, 0. But you have one length which is unique. It's a member of all sets of all lengths. It's a member of all lengths in the world. Let's put it like that. It is this. It's empty set. It means no length. It has no length. It has no length. It means this or this, or we represent it like this. So that's why we say that. Where is it? The empty set is the unique string over alphabet of length 0. So it is of length 0. It is of length 0. Let's read it again. The empty string is a unique string over alphabet of length 0. So it's denoted by this or this. It's denoted by this or this. That's the empty string. So let me erase this. Go back. So you also have this is another alphabet. You can create alphabet of length 1. If you want to create alphabet of length 1 from here, it's going to be 1. This is a string. This is another string. And if you want to create string of length 1 from here, this is a string. This is another string. This is another string. Right? Okay. But of no length, of length 2. Let me create 2 string of length 2 from here. It's going to be 2a. I can also say 1, 2. They are string of length 2. I can create more. I can create 2, 1. I can create a. I can create 2, 2. I can create 1, 1, and so on and so forth. I can create a2. So these are string, and so on and so forth. These are string of length 2. Here, can we create more? We have 2a, a2, 1, 1, 2, 2, a, 2, 1, then 1, 2. Which one can we still create? Is that all? I think that is all. Can we still create one? I don't think so. So this is a string of length 2a. We have created 1, 1, 2, 2, a. We have created a2. We have created 2a. We have created 1, 2. We have created 2, 1. So I think this is everything we can create from here of length 2. But if you want to create string of length 0, it is empty string. So empty string is represented by small epsilon or alpha from here. Okay, so but from here you can also create string of empty string from here, which means it has no length. It's this or this. But if you want to create string of length 1, what will it be? It's going to be plus then this A and 2. So you have 4 string of length 1 from this alphabet. I hope that is clear. Let's move on to the next thing. We also have what we can use to describe a group of string. We have been talking about string. String is on its own, it's not a set. This is a string, abi? This is another string, this is another string, this is another string, created over this alphabet. In fact, this is a string over this alphabet. This is another string over this alphabet. This is another string over this alphabet. This is another string over this alphabet. Length 2, length 2. Okay? So, let me erase it to make it clearer. Write another one. Okay. It's becoming too clumsy, so that it could be clear. Alright. So we can create a string from this alphabet. Then we use this alphabet plus asterisk. No, I don't want to use asterisk. Let me use slash. Then let me use 2. We can create a string from this alphabet of any length. Okay. Now let me create a string of length 3 from this alphabet. It will be plus. It will be division. It will be 2, and so on and so forth. It will be 2 plus. It could be slash 2 plus. It could be plus slash 2, and so on and so forth. This is a string created from this alphabet. Okay. Let's try to create everything. Let's try to create all possible alphabets that is existing there. Let's try and create it. Plus, minus, division, slash, 2 plus, 1 2 plus 1 2 plus 2 2. Each other one. Slash plus slash. So let's stop here because of time. Let's stop here. I don't think we have created everything. Which other one can we create? I say this is plus. We stop here. We have almost created everything. I think it should be about 9. 1 2 3 4 5 6 7 8 9. We still have another one we can create. What of slash plus? Not created that one. So let's stop here. Because of time. Let's assume we have created this from here. A string you are creating from here is just a string. It's not a set. This is a string. It's not a set. It's a string on its own. Another one is created. 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 In fact, we created how many strings? Created 1 2 of length 3 4 5 6 7 8. We created 9 strings from this alphabet. Now, the strings are on their own. The string created on their own. For instance, I can create a string from this alphabet as plus slash. This is a string. It's on its own, man. It's on its own. But we can also describe the string we are creating. We can describe them. How do we describe the string we are creating? We put them together and describe them using a language. We can describe all this using a language. Okay, so that they will not be on their own. We put them together. They will become a set, and we put them inside curly brackets this way. You can put slash plus 2 plus. We can put them together. can put them together. Okay, you can create many string from this. We can create many string, as many as possible, from this alphabet. We may decide to create two. This is an alphabet, right? We may decide to create two. Maybe for a particular reason, we might decide to create two. Just two from here. We may decide to create plus and slash from here. But how do we describe this string? If we group them together, we put them as sets. We group them together and put them as sets. We now use what? We have to describe it because we are putting them together. They are not on their own. A string is supposed to be on its own. Like for instance, from here, you may describe 2 on its own. This is of length 3. So we can describe a certain form of string using a language. That's what we use a language to do. We use a language to describe set of string. That's when you have a language. A language is used to describe set of string. For instance, we can say plus, we can say this is a string, this is another string, plus is a string, this is another string, 2 is a string, this is a string. We can just describe only these 3 strings alone using a language. So that is what a language is for. We now put them together. So a language can be used, we just select only this string alone. Okay? We are selecting only this string alone. Slash 2. Yes. From here, this is a language. Language is describing a set of string over an alphabet. It's describing a set of string. We have not been considering set of string, but we now want to consider set of string. A string is not a set, it's a finite symbol on its own. Plus is a finite symbol on its own, it's on its own. This one is on its own, 2 is on its own. But we now pick this out of this alphabet. We now want to describe them. How can we describe this one now? We can describe this one as a language. We can describe this using a language, right? We can describe this using a language from this alphabet. We can describe this language. We can say that it's a language of length 2 that have the same symbol, right? I think we can do that. Right. So we can say this one is let's call this one L3. So we can say language. So everything. Oh, let me fill the size for it. Okay, so language L3 is a set of string, or is a string. A language is a set. So the L3 is a string, or set of strings. So a language is a set. So a language groups certain strings together from an alphabet. L3 is a string of length 2, which of length 2 is a string. Control A. Let me use the size too big. Give it a very thick letter like area blank. So length L3 is a language, is a string. Is a string of what? How will we describe it? Of the same symbol and is of and this and it is of length 2. L3 is a string of the same symbol of, let's say it like this, of length 2 over the alphabet, over the alphabet summation equals to plus division, sorry, division 2. So if you want to describe this one, this is it. Language L3 is a string of the same symbol of length 2 over this. So that is this. So you can describe a language. This one now is what? This one is stops at 222. It totally have 3 string. Okay. Some string continues forever. This one that have 3 string is called finite. This finite. This finite. So this is finite. This is finite. The language that is made up of finite, it stops. Finite string. Then if I say L3 is a string, I may also say that if I say L3 is a string of any length over the string of any length over what we have here, over this. So it's a string of length 2 over this, No, it's a string of any length over this. That one will give us, it's going to be L3. That's a language. So it's equals to, it's any form of string you can combine that you can think about. So of any length, it could be plus, it could be division, it could be 2, it could be plus, it could be plus, it could be plus 2, it could be plus, and as many as you can, because of any. So this one continues to any information plus 2 and so on and so forth. So this one continues, you now put 2 dots. So this is an example of infinite sequence, infinite set of string, because it continues. Because of any length. You can keep writing any form you like. Okay, there is no restriction. So let's go back to this. A language is a set of string. So a language is a set of string. We have not talked about set of string before language. We only talk about string from an alphabet. But I've already explained language. So a language is a set of string. For example, given this, if L1 is set of all string of length 2, set of all string of length 2, then L1 is this. So you are given this. So find L1. If L1 is set of all string of length 2, this is it. I won't want to go back. I think I've already explained it. So if you are given this, If you are given this, let me use another color here. If you are given this, then L1 is set of all string of length 2, then your L1 is what? 0 0 0 1 1 0 1 1. So set if L2 is set of all string of length 3, this is it from this alphabet. Okay, now you are given this alphabet. L3 is set of all string of that begins with 0. Look at this one. This one is, now look at this. This one is finite. It stops here. This is everything you can have. This one stops here. This is everything. But this one continues. You can see 3 dots here. You can see the 3 dots. It continues forever. Okay. So that one is string of length what? String that begins with 0. So this one starts with 0. It must be all the string must start with 0. Set of all string. The language describes this set of all string that start with 0. This one starts with 0. This one starts with 0. As many as you can write. In fact, somebody that is writing this at the age of 5 will continue to write it forever until he leaves this world. So it continues. It continues. It continues. So that is, and if so, we say that L1, which is this, say that L1, which is we are giving here as L1, this is the value of L1. This is L2, we are giving L2. This is L3, we are giving it. We now say that, we say that so we say that L1 and L2 are what? Finite sets. L3 is infinite set because it continues. Because it continues, that is why it is an infinite set. And this is what makes it continue. Because it begins with 0. There will be many, as many as you can write. As many as you can write. Till the end of the world, which we don't know. I don't know the person that knows the end of the world. Nobody knows it. Now, well, some precision might be possible, but I've not heard that anybody knows the end of the world. Alright. Let's move to the next one. Now I want to talk about power of what is this? This an alphabet, which is set of symbols. Power of set of symbols. An alphabet. Usually finite. Okay. So power of this. The set of all string over an alphabet of length n. The string of length n. The set of all string over an alphabet that is of length n is denoted by, we have seen alphabet and string that are created from alphabet of a particular length. So they are denoted by summation n. We can also say summation n is the set of all string of length n. Okay, for instance, what they are saying is is the set of all string of set n. In this case, you are given this, right? You are given this set. This is of length 2, right? This is of length 2, set of string of length 2. So this one is equals to e to e raised power 2. Other than saying that L1 is a set of string of length 2, you can just say e raised to power 2 is equals to string of length 2. So that's what they are saying. String of length 2. Okay. Now for this one, if you are given this 0 1, find E3. E3 will be equals to what? E3 will be equals to, it will be equals to this. equals to this. E3 equals to this. Oh, it's pasted here. It's not coming out. Oh God. I don't know why it's not coming. Order, bring forward. Not expanding. Order, bring front. I don't know why it's not coming. Okay, I think I know what the problem is. The problem is, we'll go here, paste. Here it is. It's going. So E3 is equals to. So you can use the power of an alphabet to describe a set of string. So in this case, the set of word string of over an alphabet of a particular length is denoted by e raised to power n. We can also say e raised to power n, sigma or alphabet raised to power n. You can also say alpha or sigma raised to power n is the set of word string of length n. So, for example, let's look at an example here. For example, if your, for example, if your alphabet is this, then e raised to power 2 is equals to this. So remember, we have talked of empty sets. E raised to power 0 is the empty set. It contains no length. See, this one, e raised to power 0 is the empty set. And you can, don't forget, it can be represented by this or this. And it's empty set for any length, for any alphabet, for any alphabet. So this one is the set of all string of length 0. It does not, it has no length, So when you say E1 here, E1 is this, for this one, this is your E2, this is your E2, not E, alphabet raised to power 2. So alphabet raised to power 1 should be 0, 1. That's alphabet raised to power 1. This alphabet raised to power 3. Then sigma raised to power what is this? We don't know yet. But for this one, this is 3. Okay? This one does not really have expression based on this. But we are still going to see something like that later. There is alphabet raised to power asterisk, but we are still going there. So here is just on a property of the epsilon, which is a property of this, which is equals to this, which is string of length 0. So he said that this one is a string containing no symbol. It is not a set. Remember, this one is of length 1, this is of length 2, this is of length 3, but this one is of length 0, representing the empty set. So you are just to know some property. In mathematics, our description should be clear, and so that we will not confuse some other topics or area of discussion with another. So we have to know that this epsilon contains no symbol. So when you are describing it, it is not a set. But until when you put it together, it's a set containing one string, the empty string. It is not a set. It is a set, not a string. Okay? It is a set containing one string, which is not a string. Okay, it is not a string. So that we are saying. Then this one is an empty set that contains no string. Okay, so that's just a property. Let's leave that one for now. So when you are given this, I've said it, sigma raised power, if you are able to find sigma raised power 1, it's set of offspring of length 1, this is it. This one is set of offspring of length 2, this is it. This one is set of offspring of length 3, and this is it. So cardinality in set, cardinality is the number of elements in the set. Number of elements in the set is cardinality. So in this case, how many elements do you have here? You have 2 elements. This is anytime you use curly brackets a set. You have 4 elements here. You have how many elements do you have here? 1, 2, 3, 4, 5, 6, 7, 8. You have 8 elements. Okay. So the number of sets is the cardinality and it's denoted by this. Okay, or this. Is that okay? So if you have this is equals to 0, 1. The cardinality is written like this. Number of elements is set. We want to use this. Number of elements set is this. We use this to enclose it. 2 straight vertical lines to enclose it. This e raised to power 1. So the number of this one, when you use this vertical line, this one is 2. It's the number of elements in the set. So for this one, the cardinality is 0. So you might be giving this in your exam or test. So this one is not 1, the cardinality is 0. This one, if you are giving, that is when you are giving this. When you are giving this, you are referring to when you are giving, because this is continuation of the above. So when you are giving 1, 0, 1, okay, the cardinality of sigma raised to power 0 is 0. The cardinality of sigma raised to power 2 is what? What will that one be? You should be able to answer that one. That is 4. The cardinality of sigma raised to power 3. The cardinality of sigma raised to power 3 is 8. So it's discovered from the above that the cardinality of this value, e raised to power n, which is the length and the number of elements is this.